As another example of when a stack can be useful, let's suppose you're building something that evaluates expressions. One question that can be asked about an expression is whether the parentheses and brackets in it are well matched. It turns out that a stack is a great tool for checking that. Let's look at a simplified version of that, where we look for whether things are well matched in a string that just contains parentheses and square brackets. For example, these strings are well matched, but these are not. Okay, that feels a little complicated. Let's solve a simpler problem first. The simplest case would be if we say open parens, close parens is well matched and everything else is not. I can check that just by looking at the individual positions. Okay, let's ramp things up a bit. Now, let's make it work for strings containing parentheses, but let's continue to ignore square brackets. There are a lot of ways that we could solve this, but in order to make the transition to the full solution easier, I want to use a stack here. Remember, stacks are great ways to reverse things, and we essentially need to reverse the starting parens we have seen to match them when we find closing parens. So, this is my strategy. Let's watch that work to see why it works. First, it works on our simple open and close parentheses string. We create a stack that can only hold half the string. Since we're only pushing open parentheses, we can have no more than that many open parentheses in our string. Now, we walk through the string. We push the open parens onto the stack, and when we see the closed parens, we pop the open parentheses off the stack. That's the end of the string, and the stack is empty. So this works in the trivial case. Let's watch it work on something a bit more complicated. Since there are 6 characters in the string, our stack needs to be able to hold 3 things. Watch what happens as we walk through the string. At the end of the string, the stack is empty, so it is well matched. Let's try one that isn't well matched. For that one, our stack has to hold 2 things. But watch what happens. When we hit the third open parentheses, our push operation fails because the stack is full. So, we know it is not well matched, even though we didn't get to the end of the string. One more. The length of this string is odd. How do we make the stack be able to hold half of 3? Well, the fact that the length is odd already tells us that it isn't well matched. Finally, what about this string? 4 characters, so the stack has to be able to hold 2 characters. Let's watch it. Oops! When we see the second closed parentheses, the pop operation fails because the stack is empty. That tells us that there wasn't an open parens that matched it. Therefore, we know this is not well matched. That strategy works very well if we only have parentheses. To also match square brackets, we need to change it just a little. Now, when we see either a closed parentheses or a closing square brackets, we have to look at what we pop and make sure that it matches the closing character that we're processing. Everything else is the same. Let's watch it work on this string. And now let's watch it fail on this one. So, checking for well-matched parentheses and square brackets is a good time to use a stack because it helps us look at the opening ones in reverse order so that we can match them with the closing ones.